Hello, everybody. This video is to answer questions from 7.2.5, and that was the most commonly asked questions were on 129, 130, 131, and 132. Now, I will say that problem 132 I should not have assigned because that's a topic that we don't cover in this course, and so you don't need to worry about problem 132. I apologize for assigning that. You don't need to know how to do partial fraction decomposition. Okay, so we'll just work out the other three. For 129, to approximate the slope of the tangent line, that's the instantaneous rate of change. And so we can set this up and do the limit as h approaches 0. And then we're going to do f of, so let's see, x equals 1. So we're going to do 1 plus h minus f of 1 over h, and then we want to plug in a very small value for h, like h equals 0.00001, for example. And so this is going to be f of 1.00001 minus f of 1 over 0.00001. And so we're going to go ahead and evaluate this function at those values. To show you how you can evaluate this expression easily on your calculator, so I'll start off by putting the function in y1. So y1 is 5 to the x minus x cubed. That's the function that was given. And so to evaluate this expression on the graphing calculator, one way to do that is to go to the home screen. And so we're going to do parentheses for the numerator, and I'm going to evaluate the function f of 1.00001. And so I'll type that, I'll go to variables, y variables, and function y1. So we want to evaluate the function y1 at 1.00001 minus f of 1. So I'll go to variables, y variables, function y1 of 1. So that's just like using the f of x notation. So I have y1 at 1.00001 minus y1 of 1. That closes our numerator. I think I have too many parentheses there. Okay, and then divided by 0.00001. So that tells me my average rate of change, or my instantaneous rate of change, is about 5.05. And number 130. So we have a plane flying 540 miles per hour, flying 45 degrees east of north. So we draw an axis system. 45 degrees east of north is like this. So 45 degrees east of north. That's also 45 degrees in standard position. So, and then the length of that vector is 540. So we can write this in component form as 540 cosine 45, 540 sine 45. Remember, this is a rare case where both this angle and this angle are the same. That's the only reason why it works for this problem to just use 45 degrees. And so 540, first make sure your calculator is in degree mode, because you may have it in radian mode from a different problem. So I'm going to change that to degrees, and then go to the home screen, and I'm going to type in 540 cosine 45. That is about 381.84. And then do 540 sine 45. That's also 381.84, which shouldn't be a surprise. At 45 degrees, those should be the same. Okay, and then we have a wind vector. The wind is blowing at 47 miles per hour at a direction south 78 east. So that's 78 degrees east of south. So that's going to be about like this. So 78 degrees east of south, and the magnitude is 47. And so if you're 78 degrees east of south, then that means from standard position, that is negative 12 degrees. And so that's the value that you need to use when you change it to component form. So that's going to be 47 cosine of negative 12, 47 sine of negative 12. Remember, you always have to write the angle from standard position. And so in this case, 47 cosine negative 12 is 45.97. And 47 sine of negative 12 is negative 9.77. Okay, and so now when we add those vectors together for part A, we'll call this our plane vector P and our wind vector W. So for problem A, P plus W is equal to, so we have 381, so that number plus that number is equal to 427.81. And then we'll do the y values. So it's that 381 number again, plus negative 9.77. When we add those, we get 372.07. Okay, and they weren't actually asking for the vector, they were asking for the true speed and direction. So I'm going to move this out of the way. We did need that to get the component form, but what we really want is the magnitude of that. So the magnitude of our resultant vector is going to be the square root of 427.81 squared plus 372.07 squared. And so that is square root of that number squared plus that number squared. And that is about 566.97. So that is our true speed in miles per hour. And then the direction, we get theta equals inverse tangent of the y component, 372.07 divided by the x component, 427.81. And those are, both of those, or that vector is pointing in, since both x and y are positive, that's pointing into quadrant 1. So we don't have to do any adjustment to that. We can just do inverse tangent of the y component divided by the x component. And that tells us it's about 41.01 degrees. And that would be in standard position. So that is north of east, because the standard position is east. And so we're 41 degrees counterclockwise of that. So that would be north of east. So that's all part A. Now part B, how long will it take the plane to travel 1,000 miles in this resultant direction? So rate times time equals distance. Our rate is 566.97. We don't know the time. We know the distance is 1,000 miles. So that means the time is going to be 1,000 divided by 566.97, which is our true speed of the plane. And so that is 1,000 divided by 566.97, which was that answer. And that is going to take 1.76 hours, which is 1 hour and 0.76 times 60 minutes is about 46 minutes. So 1 hour, 46 minutes. 1 hour, 46 minutes. And then part C, excuse me, if the pilot intended to fly 1,000 miles in a direction 45 degrees northeast, how far from his intended destination is he, given the situation in part B? So let's make a drawing here. So if he flies 1,000 miles this way with a 45-degree angle, we get that triangle. So this is 1,000 miles. That's where he intended to be. Okay, and then if we instead fly at 41.01 degrees for 1,000 miles, we can get the coordinates of those points and compare the distance between them. Okay, so 1,000 cosine 45 is 707.1, 707.1. The coordinates for this point are going to be 1,000 times cosine of 41.01. That is 754.6, and 1,000 sine of 41.01 is 656.19. So it says, how far from his intended destination is he given the situation in part B? So we want to find what is the distance between these 2 points. That'll tell us how far away he is from his destination. And so using the distance formula, that would be the square root of 707.1 minus 754.6 squared. Difference in the y values, 707.1 minus 656.19 squared. And so we're taking the square root of all that. And so square root of 707.1 minus 754.6 squared plus 707.1 minus 656 squared equals 69.6 miles from his destination. Okay, and then our last one, number 131, rewrite each of the expressions in terms of x only. So that means since x squared plus y squared equals 1, we can say that y squared is equal to 1 minus x squared. So whenever we see a y squared, we want to write 1 minus x squared. So in place of this y squared, I write 1 minus x squared. Now I have the entire expression written in terms of x's only, which is what we want. So rewrite each of the expressions in terms of x only. I did that. And then in part B, same idea, replace y squared with 1 minus x squared. And I've accomplished what we wanted, which is I wrote it all in terms of x squared, or in terms of x, but this is a complex fraction, so we might want to also multiply the top and the bottom by x squared to get rid of the fraction in the denominator. So now in the numerator I have 1 minus x squared over, if I multiply the bottom by x squared, I have 1 minus x squared. And so notice that these cancel, I just get x squared. So even though this is in terms of x, you can simplify it. And then question C. Let's see, since y squared is 1 minus x squared, that means y itself is the square root of 1 minus x squared. So we have 1 over 1 minus the square root of 1 minus x squared, and 1 plus the square root of 1 minus x squared. Okay, and we now have that answer in terms of x squared only. Now you could probably simplify if you multiply both the numerator and denominator of this by, let's see, this one we would want 1 plus square root of 1 minus x squared. Do the same thing to the bottom. And then this one we would multiply the top and the bottom by 1 minus the square root of 1 minus x squared. And I think this will simplify. So we have on top, we have 1 plus the square root of 1 minus x squared over, if you multiply these two, these are conjugates, so then we're just going to get 1 minus x squared. And the same thing here, we get 1 minus square root of 1 minus x squared over 1 minus x squared. And so up on top now we have just 2. And on the bottom we have 1 minus 1 is 0, so we just get x squared for the denominator. So 2 over x squared is a simplified form. So again, what we had here in blue accomplished what they wanted, was get it in terms of x, but then simplifying, it's just 2 over x squared. And then part D, let's see, 1 over x minus y is the square root of 1 minus x squared. Okay, so the first thing we can do is try to get rid of all the fractions. So if I multiply the top and the bottom by x for both of these, that'll get rid of those fractions in the denominator. So I get x on top, I get 1 minus the square root of 1 minus x squared on the bottom. And then for the second one, again, I get x on top, and I get 1 plus the square root of 1 minus x squared on the bottom. Now this looks very similar to question C. Yeah, it is very similar, but not exactly the same. So we can multiply the top and the bottom by the same expression, to get a common denominator. So I'll multiply by the conjugate, 1 minus x squared, 1 plus square root of 1 minus x squared. And then this one I'm going to multiply by 1 minus the square root of 1 minus x squared so that we can get our common denominator. And so now on top I have x plus x root 1 minus x squared over 1 minus x squared. And then here I have x minus x root 1 minus x squared over 1 minus x squared. So again, our denominator just becomes x squared. On the numerator, we have x plus x is 2x, and the other terms cancel. And so now x over x squared is 1 over x, so we just get 2 over x is our simplified form. And that completes those 3 frequently asked questions. Again, problem 132, you do not need to know how to do partial fraction decomposition. That's not a topic we cover in this course. Have a great day.